Hi, welcome. In this video, we are going to review everything you need to know about Go context, what it is, why it is useful, really useful in our Go applications, and also specifically about this video, how to deal with context cancellation, understanding when a context gets canceled and how we can deal with that. The link for both the blog post where I talk about this and also for the GitHub repo that we are going to use during this lesson is available on the description down below. If you have any questions or any comments, please let me know so I can go back to you as soon as I can. Now let's talk about Go context. Let's say for a moment that we have something like this. Suppose that we are working with this specific Go application. And as you can see, this application is doing a lot of things. So first we have an HTTP server. And as you can see, users can send HTTP requests against our application. We also have a gRPC server and users can send gRPC requests. Also for both the HTTP and the gRPC request, we are going against a database. So we are getting data from a database, saving data to a database, but we are interacting with a database. Also, every time we process something, we are generating some files. We could be saving files on storage. We can be generating logs on the file system, whatever we are doing, but saving something on storage. And we could also be getting events from, let's say, RabbitMQ, Kafka, whatever queue system we have in place. And we need to process those events. So it is a complex application, right? Now, if, for example, we put our attention in this section here, where users can send multiple requests to our application, we can have not one, but we can have, let's say, two users like this, sending HTTP requests to our application, right? So we need a way for identifying this request versus this request. Now, this HTTP request, for example, can be coming from a payment flow where we are processing payments. So we need to be really fast. We shouldn't have any errors, and any error that we have in this flow is much more critical than an error that we might have in this situation, for example, where this HTTP request is just for, let's say, configuring an account or changing one minor configuration on your account. So we need to be able to identify these two different executions going to, let's say, the same endpoint. Even in here, if we do have an HTTP endpoint and these two users are sending a request to the same endpoint, perhaps this user is only willing to wait 1 second, and after 1 second, the user will cancel the request, while this user doesn't have a timeout configured on their system. So as you can see, the difference between this execution and this execution going to the exact same endpoint in our backend is the context in which this request is executed and the context for this another request. So Go provides a tool for us to use in order to identify and take the difference between two different executions for the exact same artifact, for the exact same function, where that context will have information that is different between different requests. And that tool, as you might guess by now, is the context. Let's take a look at the code and how we can take the difference and deal with the context. As you can see right here, we are working with this blog Go examples repository that you can find in the description down below. Today we'll be working in the examples with the context cancellation. So in here we have our main file. Here we have the package main and the main function. So as you know, inside the main package, in the main function, that's the entry point of your Go application. So every Go application you develop will be starting from the main function within the main package. In here you can see that we are creating a context, and for creating the context we are using this context package and we are using the background function. So the background context is a context that you will usually create the first time you execute the application, usually in the main file, and this is the context that will be used for executing your whole application. So suppose in this case you are starting your application and you need to initialize your database, you need to initialize your HTTP server or your gRPC server, whatever artifact you might be configuring at the very beginning. In order to do that, you will require a context. For doing that, you can create the main context using context.background. Usually you will do this in your main file the first time you configure the application. Now you can see that this context.background returns a context. If you take a look at this definition here, it returns a context, and context is this interface where we have all these different methods. Now, if we take a look at what we are doing next, is we are creating a child context from a parent context. So we do have our main context here, and as you can see, we are calling this context with cancel. The with cancel returns two things. Returns a child context that we create using this parent context, and it also returns a cancel function that we can call whenever we want to cancel this child context. Now, as you can see from here, we can use the same parent context to create multiple child contexts. So a single parent context can have multiple children contexts that we can then use depending on what we want to do with them. And right here, we are creating just one child context and its corresponding cancel function. So whenever we call this cancel function, you can see here that this with cancel returns a context and a cancel function. And if you take a look at the cancel function, it's just a function, right? So whenever we call this cancel function, we will be canceling this child context. Then we are just showing that we're about to start working. And then we call this function called do something, where we pass the child context that we created before. If we take a look at this do something function, you can see that it receives a context. So every time you receive a context as an argument for a given function, that context must be the first argument that you define on the function. Now, could you define something like this where you have another argument with different types? Yes, but this is going against the Go definition where the context must be the first argument for every function processing a context and using a context. So here we receive the context, and you can see that we have an infinite for loop. Within this for loop, we have a select statement, and you can think about the select statement as a switch statement, but working with channels. Inside every select statement, you are going to listen from one or more channels. And the idea of the select statement is that goes to the case where the first message is received. So if you have, let's say, 1, 2, 10 different channels, and you're listening from 10 different channels in here, you have 10 different cases listening for different channels. The select statement is going to execute the case where the first message is received. So the idea is that you can listen for multiple channels at the same time and process those events in the order they are appearing. So in here you can see that we have this case where we are listening for this context and we are calling the done method. Now, if you take a look at the done method here for the context, is one of the methods defined inside the context interface, but it returns a channel, an input channel, a reading channel, where we receive an struct. So the idea of this done channel is that every time you call the cancel function on a context, Go is going to send to this done channel, letting everyone listening to this channel know that the context has been canceled. As you can see, this do something function is listening for this done channel. If we receive a message here, it means that this context has been canceled. So we need to basically return or stop doing what we were doing. Otherwise, we have the default statement here where we are doing what this function is supposed to do. So in here, we are simulating some hard work that we are doing every second. So we work and we sleep for 1 second. Now, this function will keep doing this until we receive something on this done channel. As you can see, as long as we don't receive anything here, we'll keep working with this in the background until some point where we will receive a message here and we can finish the execution. Now you can see here in the main function that we execute this, do something on a different Go routine. Now what we are doing here is creating a brand new Go routine that will be executed concurrently along our main function. So this is our main Go routine, and now we are creating a new one that if you have more than one CPU, more than one core, these functions, both the main Go routine and the Go routine that we are creating now, will be executed in parallel. Otherwise, they will always be executed concurrently, meaning that they will all execute at the same time, but only one of those will be executed in the CPU at one given moment, right? Because if you remember, concurrency is not parallelism. So in this case, if you don't have more than one core, you will have only concurrent execution. Whenever you see the Go prefix here, what it's doing is launching this function on a different Go routine. And the moment you do this, you lose control about how you are going to stop this Go routine. And this is going to be managed internally by Go. So there's no Go routine API that you can use to say, stop this Go routine or pause this Go routine. Just execute a new function, and both the main file and this new Go routine will have their own execution flow. So as you can see here, we are creating the context, then creating the child and its cancel function, and then creating a different Go routine, passing the child context. Every time you see Go here, you can think like opening a new Go routine and just continue with the application. This is going to be executed in parallel within this Go routine that you have here. So we are launching this Go routine, the application continues on this main Go routine. So after launching this Go routine here, we are sleeping for 5 seconds. So this line will block in here for 5 seconds, and then it will continue the execution. So after 5 seconds, we are calling this cancel function. So we are canceling the child context created here. Then we print context cancel, we sleep for 1 more second, and that's it. So you can see that the main Go routine is basically launching this Go routine here, sleeping for 5 seconds, and then canceling the child context. Now, when this Go routine executes, it's going to start working and print working every second until something arrives to this context that's done. Now you can see that whenever we call this cancel function on the main Go routine, we are going to receive the cancellation in here on this different Go routine, and this select is going to go through this case and it is going to return. So what we are doing in here is basically using the context cancellation channel to know when to exit and when to finish this function, thus finishing the Go routine that we launch here. Now, if we execute this code, you can see that we are within the repository inside the examples folder, in this case, context cancellation. Here we have the main.go, so we can say go run main.go, and you can see exactly what we said before, about to start working for 5 seconds, the main Go routine cancels the context, work cancel, all done. So we are processing for 5 seconds, waiting 5 seconds until canceling the context gets canceled, and that's it. So as you can see, it seems like something really simple, but what if we are processing, let's say, an HTTP request? So we have the same code here. So instead of do something, we say process HTTP request. And instead of receiving a context, now we receive, let's say, an HTTP response writer and an HTTP request. And we are going to import this HTTP package. Now, this is the standard way of processing a request. So in here, this is an HTTP handler. We are receiving the incoming HTTP request. We process this request, going to a database, doing whatever we need to do. And then once we have the response, we use the response writer to send the response to the user. So, right? So what we are implementing there is this path right here. The user sends a request, we process the request against a given database, and then we return the response to the user. So in here, we do have the incoming request and the response writer. I will have appreciated having the request as a first parameter, but who am I to say anything? So in here, you can see that we are receiving this request, right? And we don't have a context right here. But one thing that we can do, if we take a look at this incoming request, that within the request, you have a context. So one thing that we can do is create a context like this and use the request context to know when to cancel the work that we need to do. So in this case, we are going to do this, and we are going to, let's say, process incoming HTTP request. So we are going to do this as long as the context or the request context is not canceled. So here we can call the database and passing this context to the database. So the database also knows that if this context gets canceled, we don't need to keep looking for data in the database because the user canceled the request. So we should cancel the processing that we are doing for that request. As you can see, we do have the context in the incoming request, but we need to use that context in order to let both the Go application and the database that this context is still alive. And if the user for some reason cancels the context, then we need to cancel the processing of that request, and we need to cancel the database query because now there's no one in here receiving the response or waiting for the response that we were going to generate. That's why if you are processing an incoming HTTP request and you are not using the request context, or even worse, you are doing something like this. So in this case, you are creating a background context for processing this incoming request. If the user cancels this request, you are never going to realize about that. You are never going to get that signal. So you are going to keep processing, wasting resources in order to generate a response that no one is going to use because the user is not there anymore. So when to use background context or when to use the request context is something really, really important in order to configure our application to execute differently based on the execution context. So as you can see from right here, I'm going to let this as it was just because we want to have that in the example. The context in Go is pretty much the standard way for carrying deadline, cancellation signals, and any other request scope value across all the different boundaries and the different Go routines. So if you receive an HTTP request from this user, this request will have a context that we need to use in our Go application whenever we are doing anything that has anything to do with this specific request. So this request will have a context and this request will have a different context. For example, if you are processing a gRPC request, the authentication data, the authentication token, or whatever you are sending in authorization metadata that you have within that gRPC request is stored in the context. So if you are processing a gRPC request, you will have something like this, where you receive a context, and inside this context, you have the authentication data. So when implementing gRPC, it's really obvious that you need to look at the context in order to get the authentication data. But perhaps on HTTP requests or background jobs, using the context is not that obvious. So that's why it's really, really important that every time that you perform a blocking operation, like using I/O, background processing, or waiting for a signal, or whatever that interacts with something outside of your application, you receive a context. In that way, you can make your application aware about different cancellations, signal, timeouts, or anything that could be defined in that context. And if you are not taking care of that, you are ignoring pretty much the context in which that request is being executed. So that's why it's really, really, really important for everyone to understand that every time you interact with something outside of your application, you need and you must be implementing a context if you want your application to process exactly what's happening in the outside world and stop wasting resources on something that no one is going to use. If you have any questions or any comments, please let me know. I hope you took something from this video. We are going to have a lot more coming up, so keep tuned. Thank you very much for your time and see you next time.